So let's do an example. We're going to titrate a weak acid with a strong base. We have 25 mils of 0.1 molar acid with 0.15 moles of a strong base, NaOH. We're given the Ka for the acid. First, we start with 0 mils of the strong base added. So what type of problem is this? It's a weak acid problem. So we know how to write the equation for a weak acid or for an acid in water. We have the acid in water going to hydronium ions and a conjugate base. So weak acid. For weak acid, we're going to use our Ka, and we're going to set up our equilibrium expression. So here we have 0.1 molar of our acid. We're going to have some of that go away in the equilibrium, forming some hydronium ion and some conjugate base. And so we know we have expressions for the concentrations at equilibrium, and we can use our Ka. Ka for acid, it's a weak acid problem, and we can look at products over reactants. So see, now we're doing a titration problem, but you already know how to do this problem because we've seen a weak acid in water problem before. So we have x squared over 0.10 minus x here. We can assume x is small and get rid of this minus x, and then later go back and check it. So that just makes the math a little bit easier. And we can solve for x. And then we can check. We can take this value, 0.00421, over 0.1, and see whether that's less than 5%. It's close, but it is. So that assumption is OK. If it wasn't, what would we have to do? Quadratic equation. All right, so now here's a sig fig question. Tell me how many sig figs this pH actually has. OK, 10 seconds. So in the first part of the problem, we had a concentration that had two significant figures, the 0.10 molar. Sometimes later, people have extra significant figures that they're carrying along, but we had those two. And so we're going to have two after the decimal point then in the answer of the pH. So again, the number of significant figures that are limiting are going to be the number after the decimal point. All right, so we have one pH value.